All right, so we've been talking about classes. A class is a blueprint for an object which contains data and the methods that act on that data. And so, for example, I think we did a point class with an x, y, and a z coordinate. I think we also did a fraction class that had, you know, a numerator and a denominator. Is that right? We've done those too? All right. So overloading methods is when you have several different methods, more than one method, with differing parameter lists. Like here is a method that called find average for 2 ints that accepts 2 integers. And here's another method called find average for 3 ints with 3 integers. And another one called find average for 2 doubles. Now that's lame. We could have just made it so that the same method, find average, would accept 2 integers or 3 integers or 2 doubles or 3 doubles or whatever. Each one would need to be created separately. We would wind up with 3 different methods in order to support that, or 4 if we wanted one to accept 3 doubles as well. And it's just to make your class easier to use so that you can use the same method name and pass in different data types. So class equals blueprint for a collection of data, or blueprint for objects that are collection of data and the methods that use it. How about I might make it say an object, so it's grammatically correct. That is a collection of data and the methods that use it. Or you can say it's variables and the methods that use them, right? So a collection of variables and the methods that use them, right? Whichever way. And so methods can be overloaded, meaning the same method name with different parameter lists. Now they actually have to be different parameter lists, really different, not just like this. This, right, and then giving a, you know, an int and calling that one x, and then writing another one that had a different parameter variable name. That's not going to work, right? They actually have to be different types for it to work, or different numbers. So you could write one called foo that took an x. You could write another one called foo that took a double. And you could write one, you know, that took a string. And for whatever purposes, right? Who knows what foo's going to do. And that way you could call the foo method and pass in any of these 3 kinds of data. Now overloading is not bad, it's good. Overload sounds bad, you know, like the engines are overloaded, but it's not, right? And so who knows what foo and foo and foo are going to do? You know, so inside here you would put some good, you know, useful stuff that actually uses that data. So you have 2 kinds of variables in a class. You have what are known as instance variables. And then you have something known as class variables, which are defined with the static keyword. Instance variables differ on an instance-by-instance basis, or they can differ on an instance-by-instance basis. You know, I have a different name than Shannon, and I have a different height, or maybe I don't, right? But I could, right? Each one of us is an instance of a human, and we each have different attributes. We each have different instance variables. A class variable is a little bit of a more subtle concept. It's data that's shared by all objects. And as a matter of fact, it's not attached to any object at all. So you can access it without having an object. So instance variables apply to each object. Class variables apply to the class itself, meaning you don't have to have an object to reference it. Now let's define some. Let's get some examples going. Just for total funsies, though, let's make this a jframe application. We may not even do anything with the jframe application, but I just want to get used to the idea. So do new project, call it lecture V, lecture V, but remove the thing that says create main class. We do not want a main class. If you leave that create main class thing, it's not going to work, and we'll have to go and delete the main class that you just created.
We're still creating it with ant.
Sure, right, okay. Right. Although if you use Maven or whatever, it doesn't create a main class anyways, and so that would work just as well. All right, then come down to source packages, and we're going to add a jframe. So new jframe form, and call it lecture V. Or you could call it lecture V frame, since it's a frame, right? Doesn't matter. And you click finish. That gives us this little form designer and also a palette of tools we can use. Now, just to begin with, we're not going to have anything on here except for a button. If we run it right now, it'll say please select the main class because it didn't have one until we added that jframe. Eventually it'll run, and there's our window with nothing in it. Now let's add a button to it. So find your swing control properties. Excuse me, your swing control palette. If you can't find it, it's somewhere. Not sure where. Hopefully it's over here. Grab the button and drag it out. And let's edit the text. So I'm going to right click on it and choose edit text and just make it say click me. Now that's enough for us to get started. All that click me is going to do is it's just going to do the same kind of stuff that our main method used to do. It's going to system.out.print, to the output. It's not going to do anything else with a window. But if we have time, we might modify this to actually do stuff with the window. But for now, no. So we need to create a method that is triggered by the click me button. Well, if we right click and choose change variable name, it's got a really lame name, jbutton1. I would rather rename it to something that makes a little bit more sense because I might have 20 different buttons on it. And I don't want to just call them jbutton1 and 2 and 3. So I'm going to call it jbutton_click because that's the text on it, or jbutton_click me. Now it could be anything you want, right? You can call it Fred, you can call it button 75643, whatever. Now I'm going to double click on the button. Don't double click on the text in case it offers to edit the text. Sometimes it does. Instead, click somewhere else on the button and it adds the method that is invoked when the button is clicked. But it took us to the place where the button was declared. I'd have to scroll up and down and find a place where it was really where the method is. That's the variable. So I'm going to click back on the designer, double click it again, and there it took me to the method. Right? You're not going to take me to the method? There he is. Click me, action performed. If you can't find it, just do Control F and look for performed, and it'll take you straight to it. So as we look at it, what does it do? It says add your handling code here. Yeah, let's do it. System.out.println parentheses quote I've been clicked. Exclamation point, end quote, in parentheses, semicolon. Now when I run it, there it goes, right? If I click me, to the output, if I ever find my output window, I don't remember where I've hidden it. Oh, right over here, right? I've been clicked. just like before, right? Except now we have something that's triggering it. So where's our main method? That's not a main. Well, main is below it on mine. And all main does is it creates the form. So when Java launches it, it jumps down to the main method and it creates all the form and it runs it. But then the form just sits there waiting for us. And if you get more than one instance of the application running, look down here where it says one more in that little click box. Lecture V run. You can close all the currently running applications in case you accidentally get more than one window going. All right, so let's create a class. I've almost forgotten the whole point of the lecture. I better come back and look over here. Oh yeah, instance variables versus class variables. We're going to create a class called ant, A-N-T. Why not? Because we're using the ant editor. And all it has is some string called type so that we can call it, a fire ant versus an army ant. And I should put it in a separate file, but forgive me, I'm just going to scroll up to the top and put it right here. Class ant. And it's going to have a public string, which we should make private. Whoops, don't put the colon there. That's C++. Public string type. And let's make a constructor that sets the type. So, back to our notes. A constructor is a method with the name of the object, no return type, and is called by the new keyword to create the object. If you do not give a constructor, Java gives you one automatically called the default constructor. You don't see it. It's just that the compiler says, okay, you didn't give me one, so I'm going to make one for you. And it doesn't do anything, right? It's a default constructor because it has to have some way of, making the object. But we're going to replace the constructor. We're going to add our own custom constructor. So it has the same name as the class, so public ant. It has no return type, and you can give it optional parameters between the parentheses. Well, the whole reason I want to do this is so that I can set the type. So I'm going to do string space type. And what is it going to do? This.type equals type, right? So if we say ant equals new ant, parentheses, quote, fire, then type is going to be set to fire. Maybe I should have stuck this in its own file. Why do I say that? Because I'm going to have to be doing a whole bunch of scrolling up and down. Make sure this builds and then tell me if you're done typing this or not, because if you need more time, I don't want to scroll past it. Are we okay? Mm-hmm. All right. So I'm going to go back down to my button. Action performed. I've been clicked, and I'm going to create an ant. Ant A1 equals new ant, and this is a fire ant. Or maybe just fire, right? In quote, in parentheses, semicolon. And how about a second ant? Ant A2 equals new ant, army ant. I really don't know any more kind of ants than that, and I'm sure that there are 70 billion of them. Now let's add a toString method so that we can print out the method, the ant like this. System.out.println parentheses A1 in parentheses semicolon. System.out.println A2, right, like that. Now right now that's not going to do anything useful because we don't have a toString method. So when it runs, and then I click my button, wherever it went, click me, it just prints out this stuff. I need a toString method to replace that stuff with some useful stuff. So let me kill the application by clicking the little checkbox. And then I'm going to scroll back up to our ant class. We're going to add a public capital S string space lowercase 2 capital S string parentheses in parentheses. And we need to build a return string. So string S equals quote ant comma type equals space end quote plus this dot type semicolon return S. And the little warning will just add that override tag that we saw in the last couple of lectures. Alrighty. Kind of wave your hand when you're ready to go. We all good? It all builds? All right. So I'm going to go back down to my action perform thing. Well, I guess I already got it, right? So it should be printing out my ants when I run it and click that button. Click me, right? I've been clicked. Ant type equals fire. Ant type equals army. What if we wanted another piece of information, like the name of the ant? One ant's going to be called Fred and the other's going to be called Barney. Well, we could create a new instance variable. This is an instance variable because it doesn't have the static keyword in front of it. Each ant can have its own type. So this is an instance variable. A class variable is one that applies to the class and not to any instance. And that's a vaguer concept. But like all Rose students go to Rose. And so the name of the school is something that applies to all of us. Well, how about a counter? Each time we create an ant, we're going to increment a counter. But it's not like each ant has its own counter, right? It's not like the army ant has a count of 2 and the, or I mean, I guess we could do something like that. But instead, we want the counter to apply to ants as a whole. And if we haven't created any ants, we want it equal to 0. Let's do that. Public static int count equals 0. Well, let's go downstairs into the perform, and let's print out how many ants we got. We don't have anything incrementing it, so this isn't going to work, right? But system.out.println, parentheses, quote, ant count equals, end quote, plus ant dot count, in parentheses, semicolon. Notice that, well, other than the fact that we have an error, I put my semicolon in front of the parentheses. That's dumb. There we go. Notice that we prefix this variable with the name of the class and not any particular instance. That's because count is a class variable. So the thing before the dot is a class name, not an instance name. You might be able to put an instance name there, but then NetBeans is going to call it a warning if it allows you to do it at all. I'm going to test that out. I'm going to type in A1, don't type this, A1.count equals 3. I'm going to delete that in just any minute. Right, see, it's warning me. We're accessing the static field count, replaced with a class reference. That's the right way to do it, right? And notice that we have a count of ants even before we create any ants, right? It compiles nice, like that, right? Doesn't do anything, but if we ran it, it would say we have 0 ants. Now let's copy that line and paste it down here after we print out our ants. And let's print out the count again. It's going to be 0 again because we never made anything that would increment it. But that's going to be the thing we do next. All right, so I've been clicked. Ant count equals 0. Ant type equals fire. Ant type equals army. And the ant count is still equal to 0 because nothing is ever incrementing it. We're going to make the constructor increment the count so that each time we construct a new ant, the counter goes up by 1. Let's do that. Come up, find your constructor. And we're going to say count plus plus. Notice we don't say this dot count like we do everything else. It might compile, but it's going to give us a warning. And the reason why is that count is not an instance variable. It doesn't apply to this ant. It applies to all ants. So remove that this dot. All right, now when we run it, it's going to show us that before our ants run, we have 0 ants, and after them we have 2. Oh, I haven't run it yet. I just compiled it. All right. Ant type equals fire. Ant type equals army. Ant count is equal to 2. This applies to the class as a whole. If we were good programmers, we would add getters and setters for all of our data types. And we know how to do that, right? We just highlight that line and we say refactor, encapsulate. You know. Or I could add them by hand, which is good practice. Because if I asked you to write a getter and a setter on an exam, it'd be lame if you had to load up NetBeans. So let's provide a getter and setter for type. So public void set type, parentheses, string type, in parentheses, curly brace, this dot type equals type, semicolon, close curly brace. That's the setter, which is also known as a mutator. And then public, what type of data is this variable? So what should it return? Type is an int, a double, a string, a boolean. What is type?
A string.
It's a string, so he needs to return a string. The getter needs to return a string. Get type, but it doesn't accept any parameters because we're just returning the state of that variable. Return this dot type. All right, and yeah, we could have used encapsulate to do that real fast. And this is the, what is that called? I momentarily spaced on it. What is a getter called? Anybody remember the Latin term for it? Accessor. Here we go. That's what the book will call it. It's book correct. Alrighty. So, props rules, props guidelines, skipping the fact that class name should begin with a cap and class should be in its own file. Those are like a given. I want us to remember data private, methods public, add constructors if it makes it easier to use, actually 3 is usually add getters and setters, add constructors if it makes it easier to use, add toString, if you want to make printing the object easier to, right, print something useful. Add dot equals to compare 2 ants or whatever. Add dot equals if code will be comparing objects, right? If you want to say if O1 equals O2. And then one other thing that we added before was I add a .clone method to make copying the object easy. Why would you do that? Because if we did this, if we went in and did A2 equals A1, that doesn't copy the data out of A1 and put it into A2. Instead, we just have two references to the same ant. Just like you have two street signs pointing to the same street. Or you have two pieces of paper with my home address on it, right? It's the same thing, right? You go and burn down my house, then both pieces of paper have the address of a burned down house. If you have two street signs pointing to the same street, and you go and you pave the street, now you have two street signs pointing to the same paved street. If we did this and then we changed the type of one of these ants, right, to whatever a third kind of type is, a black ant, right? I don't know, a red ant. Yeah, red ant. If we changed A1.redAnt, then when we printed out A2.type, it would also say red ant, because they're just pointing to the same ant. So that's why you make a clone method. The clone method copies the data from one to the other. I don't know that we need to, but maybe I'll just add a little comment here. Right, things we might want to do, right? Add a clone method, add a .equals method. That's enough. Alrighty, well, since we have this form here, let's actually use the form. What do I mean by that? Let's make it so that they can type in a type of ant. Have we done array lists yet? Have we done arrays yet?
It doesn't sound familiar.
Oh my gosh, I can't believe we haven't done arrays yet. Alrighty, well, we need to do arrays real soon, but I guess I'm going to go ahead and finish this example since we started it. I'm going to go back to my designer, and I'm going to drag a label out. Where's my swing palette? There he is, palette. I'm going to drag a label out, and I'm going to change its text to ant type. And I'm going to drag a text field and put it next to it so that the user can fill in the ant. And instead of click me, I guess I'm going to call it create. So I'm going to edit that and make it say create. Now let's make a little field that displays the count of the ants. So that's going to be another label and another text field, right? I don't care where it goes. The label is going to say ant count. Maybe we could put it underneath it, right? Now it's kind of lame for this stuff to have all this text in it because jtextfield1 is a really lame name, right? You're not going to create an ant called that. So I'm going to right click on it, choose edit text, and just backspace over it. But when I do that, it's going to shrink it down. I don't like that, so I'm going to stretch it back out so that they could type in a name. Same for count, except I'm going to actually fill it in with the number 0 to begin with. Edit text, I'm going to put a 0 there. But I'm going to kind of stretch it back out so that the count could get larger if need be. And you could spend forever being real picky over these interfaces. Alrighty. And lastly, we might want a scrolling list showing all the ants as we create them. So I'm going to grab a text area. A text area can have multiple lines of output. Now I should give these variables better names. What do I mean by this? If I right click on that text field and say change variable name, it'll just say jtextfield1. But it's really the ant type, right? So I'm going to make it say jtextfield underscore ant type. And this is ant count. Right click on that one, change variable name, jtextfield underscore ant count. I'm not going to bother changing that variable name though, right? Create, it has a dumb name because its name is clickme, so I'm going to right click on it and change its variable name to jbutton underscore create ant. Now remember, variable names don't mean anything to the computer, they just mean something to us. So we could have left them the same, left them what they were by default, but it makes our code easier to read if we give good variable names. Alrighty, so when they type in something here and click create, we want to create an ant, which is going to increase the count, and add the type of the ant to this thing. So we're going to need a couple of things here. Where's my J action performed? I'm going to delete most of this stuff. We're going to start over. No longer is it going to say I've been clicked. I'm going to say creating an ant. We need to get the type of the ant out of that field. So string space type equals, and that field was called jtextArea underscore ant type, something like that. Well, I don't remember it, so I'm just going to type this dot jtextArea, and there it is, ant type. Dot get text with a capital T. Those fields are strings. They can't be numbers. Well, I mean, you can type in a number, but the data comes in as a string. And if you've done Python programming, you remember that. Every time you got input, it was a string and you had to convert it to the data that you wanted. Now, we've had it easy because we've had scanner.nextInt and whatever to read in, you know, ints and stuff like that. But not when you're creating jframe forms. All right. Why don't we move this print statement down underneath this and make it say creating space end quote plus type plus beginning quote space ant. So it'll, like if it's a fire ant, you know, or a black ant or a red ant or army ant, annoying ant, right, whatever. Great ant. Sorry. All right, so now let's make an ant. Ant A equals new ant parentheses type in parentheses semicolon. Then we need to update our display. But we also need to add our new ant to the console. We could create a method for that, or we could just do it right here. Let's make a method that adds to that console, that scrolling text area. So underneath the close brace, private void add to text area parentheses string s end parentheses. And what this method needs to do is it needs to pull the text out of that scrolling text field, text area, concatenate s onto it, and then stick it back in. So string space text equals this dot jtextArea 1, since we didn't give it a better name, dot get text, parentheses in parentheses semicolon. Get the text out of there. Now add our string to it. Text plus equals s plus quote backslash n. because we want each thing we add to it to be on its own line. And then set text with that. This.j text area 1 dot set text parentheses text. We got the text out, we appended something to it, and we're adding it back. Well, let's add our ant to the text area. So, add to text area parentheses type plus quote space ant end quote in parentheses semicolon. Or maybe we could call ant.toString, right? Just ant.toString. But if you remember, adding that toString business is optional. So I'm just going to say A. We're going to rely on the toString method. Or not. Why are you underlining me? Ant cannot be converted to string. We didn't add a toString method to ant. Oh, yeah. Okay. A.toString. We shouldn't have to do that. All right. Oh, I know why. Oh well. Just live it with that. Okay. Now our user interface is almost done. The only thing it's missing is an update to the counter field. Right, so fire, create, army, create, funny, create, black ant, create, right? And so it keeps getting the text out of that text area, but it's not updating the count. And this is editable. We might not want that to be editable. So we're going to want to try to make that read only. Same for the count. We don't want them to go in and type 20 there. So we're going to flip back to the designer, but does anybody not working? Because I've been going kind of fast.
It looks like it's working.
Pardon me? I have it.
We have several copies of it running. Why don't we see if we can close them all?
Okay.
I mean, maybe that's not a problem, but let's check to see if it fixes it if we delete those.
Okay.
Creating an ant, we got that, but it's not filling that in. Okay, so go back to your action perform method. And by the way, you've got a lot of extra action perform made by double clicking on other variables. That doesn't break it, so don't worry about that. Okay.
So that's what this is.
All right, so after this new ant type, add one more line.
Okay.
So you're going to want to add that. So the last thing we want to do is update a counter. Right, we have a counter field as well. We could just update it every time we call add to text area. Or we could make a separate method to do it. Or we could just update it right here. But why don't we make a whole new method for it? Private void update counter. And we're not going to pass in any arguments because we're going to get the counter from the ant class. Right? So string s equals, cheap and easy, Nah, not cheap and easy. Let's do it the right way. Integer dot to string parentheses in parentheses, and inside those parentheses, oh, let's get the counter out this way. Int I equals ant dot count. Or did we change it to get count? No, we never added a getter for it. Okay. And then integer dot to string I, and now we can set that field, right? So this dot j text field count, or whatever you called it, dot set text parentheses s. So each time we call update counter, it's going to ask the ant class, how many ants have we created? It's going to build a string based on that, and it's going to set that counter field. So let's do that up inside create action perform. After we add it to the text area, we're just going to call update counter. So fire ant, big ant, little ant, and it's updating the counter. Now this is a silly application because it's creating new objects, but it's not storing them in an array or anything like that. But it's proving the point, and we're getting a little bit more experience using the editor, the form. The last thing I want to do is make this read-only. And if you didn't make this a label, we're going to make that read-only as well. So we're going to go back to the designer. We're going to select the field that we want to be read-only. Go to the properties. If you don't see the properties, you ought to be able to right-click and choose properties. And hopefully there's one called read-only or editable. We don't want it to be editable. Same for count. Now since you made yours a label, you don't need to change it for count. Labels can't be edited. Right? Why is that one already disabled? Are they all disabled now? Why did I have everything highlighted? And type definitely should be editable. All right, what's going on? Why is it changing it for everything? I don't know. Maybe I found the wrong thing. All right, editable doesn't seem to be the trick. Let's find one to see if there's one called read-only.
No, I don't. Might just be the different versions, but mine's working fine on editable.
Oh.
Yeah, it works for me.
Okay.
Like I can't type anything in the count box or the bottom box, and I still can in the ant.
Oh, when I right-clicked on it, it's not working, but if I do it over here, it does work. Okay. And they fixed that bug in your version. All right. So I can't change these things. If we had all the time in the world, the next thing we would make it do is that after we typed in a type, we could just hit the enter key, right? Rather than have to click create.
Mm-hmm.
And, you know, that would be cool. But we're not going to do that because I want to get to our next topic, which is arrays. And I'm sure you've seen lists if you took Python, or you've seen arrays if you took C++ or whatever, but I want us to hit the concept anyways. So we're pretty much done with this example here. And I'm pretty proud of it. I think we did something pretty cool. But we're going to demonstrate arrays. So go back to your source code, find your JButton create ant, and we're just going to add some stuff to the bottom about arrays, even though it doesn't have anything to do with, you know, the user interface. I don't feel like making a new program. Let's make an array of strings. String. Now, in the past, we've given a variable name there, right? But to declare an array, Lindy's used to seeing it in C++ where you typed in the name first and then the square braces. Java's a little bit different. You put the square braces first and then the name of the array. So I'm going to call this colors. And you don't need to put so much space there. And I'm going to list some colors. So equal, curly brace, quote, red, end quote, comma, quote, green, end quote, comma, quote, blue, end quote, curly brace, semicolon. And let's print out one of them. System.out.println, parentheses, colors, subscript, and when I say subscript, I mean inside square braces, I, in square brace, end parentheses, semicolon. Where did I get I from? Spacing out, 0. Now, just like strings, it's 0-based indexing. So that's element index 0. That's element subscript 1. That's element subscript 2. So when we say print line colors 0, it's going to print out red when we click our magic button. Red. And of course, it's going to do the same thing every time we run it. That's all right. Let's change that element to something else. Colors subscript 0, not lowercase o, 0 in subscript is equal to silver, end quote, semicolon. Let's print the whole array out. Now there's a for each loop and there's a for loop. There's an index-based for loop and then there's a for each loop. Let's use the index-based loop first because it's actually more important to understand that. So for, parentheses, int I equals 0, semicolon, I is less than the length of the array. Fortunately, there's an easy way to get the length of the array. Here's how you did it in Python, which isn't how you do it in this language. You type in the name of the array, colors, dot, length, like that. If it was a string, you would add the parentheses to it. But it's not a string. Semicolon, I++. Let's print it out, maybe using printf to make it look prettier. System.out.println, no, printf, parentheses, quote, array element %d equals %s, right? Because we want to print out the value. So after the end quote, comma, we're going to print out I, followed by colors subscript I, in parentheses, semicolon, but I forgot my \n, so I'm going to have to come back and modify it to put the \n there. Now I'm not seeing my curly braces, but that's probably just because I've scrolled too far off the screen here. Yeah, there they are. So %s \n. That should print our array. And so as a matter of fact, I think it probably did. Right? Element 1 is silver, element 2 is green, element 3 is blue. So we started off with red, green, blue, but we changed the first element to silver. Now this is what's known as using an initializer list. We're initializing the array with the curly braces. But you don't always have to initialize it. In fact, it's a good idea not to. Like, what if it was 10,000 spaces long? You would not want to have to use curly braces and put in 10,000 things between the curly braces. So let's redefine colors, or make a new array. Int space, or int, square braces, nums, equals, new space, int, square brace, and this needs to be big enough for 10 ints. So subscript 10. That makes an array of 10 ints. That's a 10 int array. We can access subscripts 0 through 9. Because if we count on our fingers, 0 through 9 really is 10, right? In other words, the highest subscript you can access is n, where n is equal to length minus 1. If this was 1,000, the highest subscript we could get to would be 999. If it was 4, the highest subscript we could get to would be 3. Well, let's put some numbers in, right? Nums subscript 0 equals, and just put in some number, I don't care what. Num subscript 1 in subscript is, you know, some other number. Num subscript 2 equals whatever. Now, instead of an index-based loop, which is what this is, print the array with an index for loop. We're going to use a for each loop to print this one. For each loops are cool because the syntax is so much easier. However, there's a drawback, which is that you don't have the index counter. We're not going to be able to say 0, 1, 2, but we will be able to print out the values. So for parentheses, now this is an array of ints, so int value colon nums. For every value in nums, sometimes I abbreviate it V, or E for element, system.out.print ln parentheses value. Now we can't print out the index. That's why I didn't even bother using a printf, because we don't have an index. So you don't see an index counter in here. So it's a simpler syntax, right? We're not printing out nums subscript I or anything like that. We're just saying for every value in nums, print that value out. Much shorter syntax. But the drawback is that you don't have an index counter, right? Which you might find useful for some purpose, like when we printed this out. But if you don't need an index counter, this is certainly the easiest way to print it out. So it's an array of 10 numbers long, but we only added 3 numbers. So the rest of the elements are going to be to their default value, which is just 0. Right? 0, 0, 0, 0, 0, 0, 0. So here's the first 3 elements of our array, followed by 7 zeros. Since this is an array of ints, anywhere where an int worked, an array element will work too. Like we could do this. Int x equals math.pow parentheses num subscript 0 comma 2, right? To raise that thing to the power of 2. I don't know where that word abort came from. Is it not liking the fact that this is returning an int? Yeah, I need to change that to a double. Right. So, you know, rather than using a number here, I used an array element, and it worked just as fine. Right? And then double y is equal to nums nums subscript 1 in subscript plus num subscript 2. Right? Just like you could add 2 ints together, you could add 2 array elements together. Well, I guess I didn't change the output, so I don't know why I'm running it and inspecting it. Anybody have any typos that you'd like eyeballs on?